This video will walk you through calculating and interpreting a multiple regression for a dummy or indicator variable where you have more than two choices. So here I'm looking at the data set, I think it's Metacorp 7, and I have information about sales, the amount spent on advertising, the amount of bonuses received by the employees, and the sales region. The regions are coded 1 for South, 2 for West, and 3 for Midwest, because those are the 3 regions where the company operates. So I have a dummy variable with more than 2 options, and here instead of like 0 or 1 and 1 and 2, I have 1, 2, and 3. So the first thing I need to do is take this region variable and transform it. So I want to create new dummy variables, South, West, and Midwest. Okay, so I'm going to use my if function to create these. So if region equals 1, then put a 1 for South, otherwise put a 0. And I'll copy that all the way down. And so now I've transformed this dummy variable from 3 choices into a new dummy variable which only has 2 choices. That new dummy variable is South, and it now takes a value of 1 if we're talking about the southern region and 0 otherwise. Then I'll do the same thing for West. So if region equals 2, because category 2 was my West, then put a 1 here, otherwise put a 0. And copy that down. And I will do the same thing for Midwest. So if region equals 3, this variable becomes 1, otherwise it becomes 0. Okay, now I have transformed my region dummy, which had more than 2 choices, into 3 separate individual dummies which each have 2 choices. But since I have 3 choices, I cannot include all 3 choices in my model because that would introduce perfect multicollinearity into my model, which is a bad thing because X correlated with Y is good, but X correlated with another X is bad. And so if I had all 3 of these dummy variables, then I would have perfect multicollinearity in there because I only have 3 choices. So all 3 of those would be perfectly related. So what I'm going to do is select one of them to be my base group. Since we're in the Midwest, I'm going to select my Midwest as my base group. Now, once I've selected my base group, that means that I do not include that dummy variable when I run my regression. So when my regression is run, my base group is not included. And then my regression gives me the coefficients relative to that base group. So in order to go through and run my regression, I actually have to have all of my, insert 2 new columns in here just so I have all of these right next to each other. Control C, and then I am going to go into paste, paste special, and I just want the values for those 2 columns. Okay, so now that I have my data next to each other, I can actually run that regression. So data, data analysis, regression. My dependent variable is going to be sales. Carry this down. My independent variables are advertising, bonus, and then 2 of the 3 dummy variables. So I've selected South and West. I have labels. I want a 95% confidence interval. And let's put this regression right here. This is going to be my full regression. I'll click OK. All right, so now it spits out my regression equation. So this gives me the regression equation, I have 435 plus 1.37 roughly advertising plus 0.97 bonus minus 257 south, roughly minus roughly minus 258 south, and then minus 210 west. All right, so if I am in the Midwest, then the dummy variables of south and west are equal to 0. So my regression equation would be 435 plus 1.37 advertising plus 0.97 bonus, and I'd be done. If, however, I am in the southern region, then my dummy variable on south would be 1. Well, if my dummy variable on south is 1, then I'm taking 1 times negative 257. So that's, now I have an equation that has two numbers. So I can simplify that, the two numbers being the intercept and then minus 257, 258, roughly when I round. So if I take that 435 intercept and subtract off 258, then my new equation, if I'm actually in the south, is equal to, or it would be sales is equal to 177 plus 1.37 times advertising plus 0.97 bonus. The same thing would apply if I'm in the western region. Then my value of south is 0, but my value for west would be 1. So I would multiply 1 times negative 209. Again, I can just subtract that from the 435, which I have as my intercept. So if I'm in the western region, my regression equation would actually be 225 minus 1.37 times advertising plus 0.97 times bonus. Okay, now I'm really tempted to just look at these p-values here and say, oh yeah, both west regions are definitely significant because those p-values are less than 0.05. Everything's great. But I can't, in fact, do that. In order to test whether or not these region dummy variables really do have a statistically significant impact, I need to go and run my partial F test. So I'm going to go back up here and I'm going to label this as my full model, and then I'm going to run a reduced model, which is going to be my model where I do not include my two dummy variables. So I'm going to go back into data and data analysis, regression. My dependent variable will still be the same, but now my independent variables will just be advertising and bonus. So not including those region variables, and I'll want to put this output right down here, and I'll call this my reduced model. Okay, so I'm going, in order to run my partial F test, I'm going to use my partial F test equation, which is going to require me to have the standard errors for each of the models. So standard error I'm going to need for the full and the reduced. So the standard error for the full was right there. And the standard error for my new reduced model, I'll find right down here some squares for the residual is my sum of squared errors, because residual means errors. Okay, so I have those two numbers. In order to run my equation, I'm also going to need N, K, and L, where N was the number of observations that I had, and that's 25 in both models. K is the number of independent variables in my full model, which was 4, and L is the number of independent variables in my reduced model, which is 2. Okay, so now I'm going to go in and calculate my F statistic. Okay, my F statistic is equal to, sum of squared errors from the residual minus sum of squared errors from the full, sum of squared errors from the reduced minus sum of squared errors from the full, that divided by k minus L, and that's my numerator. All of that is my numerator, so I'm going to go back and put all of that in parentheses. And then my denominator is the sum of squared errors from the full divided by the quantity n minus k minus 1. And all of this is going to be my denominator, so I need to put an extra parenthesis around there. Okay, now I need to calculate the p-value on that F statistic, or the critical value on that F statistic. So F crit is equal to F inverse, the probability, which I want is 0.05, because that's my acceptable level of scruptitude, comma, K minus L, and then degrees of freedom 2 is n minus k minus 1. Okay, and I'm going to reject if f is greater than that critical value, and 17 is definitely greater than 3, or 3.5, so I would definitely reject HO here. HO is that my new variables in my full model do not add value to my regression, so by rejecting HO, I'm saying that region really does have a statistically significant impact on sales. And again, I had to go through and do all of this because I can't just look at those p-values in order to conclude whether or not those region dummies really do have a statistically significant impact. I had to go through and perform this partial F test. Now remember, you will have the F test equation on your equation sheets. It's the same partial F test that we have covered in previous chapters. So now I'm going to show you how to create those dummy variables and calculate these same things in SPSS. Let's bring our data set up here in SPSS. Drag this over. All right, now in SPSS, when I go to create my new dummy variables, what I need to do is go into transform and then go to record into different values. And I'm going to select my input variable as region, and its output variable, I'm going to need to do these for each of the independent or new independent dummy variables I want to create. So the first one I want to create is going to be south. So I'm going to use region and use that region and use it to create my new output variable south. So if region was 1, then the new value is still going to be 1 because we're still in our southern region. But if the old value was 2, which told us that we were in the west, then its new value is going to be 0. And if its old value was 3, which meant Midwest, then its new value is going to be 0. And then I will click Continue and click Change, then OK. And go back into my data viewer and see it has now created a new dummy variable, south. So I can go and do the same thing, transform, record into different values. Now I'll have to click Reset in here again, bring over region because that's what I want to change, and I'm going to create a new dummy variable, west. Okay, old and new values. Well, if west was 2, then, or if region was 2, then west will be 1. So I'll click add there. If region was 1, I now want it to be 0 because that's not in the west. That would actually be in the south. And if region was 3, I also want it to be 0 because that would tell me that it was in fact in the Midwest. And I would click Continue and then click Change and OK. go back to my data editor, and I can see that it did in fact change those two new values. So now I want to go in and run my regression again. So go into regression and then linear. My dependent variable is sales. My independent variables are advertising, bonus, and then 2 of the 3 regions. So here I only created 2 of the 3 dummy variables. I recognize that Midwest is going to be my reference variable, so I'll put South and West both in here and click OK to run my regression. Okay, and you'll see I'm getting that same basic information. And remember, this is all relative to the base group, which is Midwest, the variable that we did not create. So again, just for practicality purposes, if you're in the Midwest, sales are equal to 435 plus 1.37 advertising plus 0.975 bonus. If you're in the South, then sales are equal to 177 plus 1.37 advertising plus 1.97 bonus, and so on and so forth, exactly as we saw before. Now that would be our full model. We would then go through and run the reduced model and do the same partial F test as we saw doing in Excel, and it may actually be easier to do that step in Excel if you wanted to go through. But either way, you can still find the sum of squared residuals is located right here, so that's your SSE full. You'll see it's the same number as under sum of squares and then residual, because remember SSE, sum of squared errors, your residual is your error.